Alright, we left off on the last video with divergent boundaries. We just did the ocean and two diverging ocean plates, which would create a mid-ocean ridge or seafloor spreading. Now we're going to do two continental plates that are diverging. Whenever they pull apart, the area here in the middle is going to be called a rift valley, and that's pretty much all there is to it. Let's go ahead and go on to converging boundaries. Converging boundaries always push together. And basically, because they're pushing together, think of this kind of like a car wreck where like the hoods of the car bend upwards. It's always going to cause the Earth's crust to bend and buckle upwards. So you're always going to get basically the feature is always going to buckle upwards and get higher. So the converging boundaries. If you have two land or two continental plates coming together, they're going to push together and create very tall mountains. So you're always going to get tall mountains out of these. Now, a really good example of this is going to be the Himalaya mountains. They have Mount Everest, K2. Some of the tallest mountains on Earth were created when that Indian plate pushed into the Eurasian plate. Let's go ahead and look at an ocean plate converging with a continental plate. Now, when you have an ocean plate converging with a continental plate, it'll create two things. On the continental side, remember that it's always going to buckle and cause the land to go higher, so it's going to create volcanic mountains. On the other side, on that part that's basically subducting here underneath the continental plate, you'll have a deep ocean trench. A good example of this is the Andes Mountains. You have a very tall volcanic mountain range on one side, and then you have a very deep trench on the other side in the Pacific Ocean. Alright, let's go ahead and look at when we have two ocean plates converging together. Alright, when two ocean plates push together or converge, you're going to create two things. You're going to have a mid-ocean trench or a deep ocean trench, and you're going to have arc islands on the other side. All an arc island is basically a large volcano that has come up out of the ocean and creates an island. The Aleutian Islands are a great example of arc islands. So remember, when you have converging plates coming together, you always cause a tall landform on the other side. And just the location determines on what is formed. It makes sense that two ocean plates would form an island. Two plates that are made of land, like two continental plates, would make tall mountains. Alright, let's go ahead and move on to our last one, which is going to be a transforming boundary. A transforming boundary is when two plates basically push sideways to each other, and it often causes it to basically crack and slip, and when that plate slips, it creates what we call a fault line. And fault lines produce our large, massive earthquakes. Probably the most famous one is going to be the San Andreas Fault in California, but there are several of these near Japan and China as well. Alright, that wraps up basically the crustal features that are formed from plate tectonics. And we'll go ahead and take a real quick look at how we deal with topographic maps, and we'll be done. A topographic map basically is designed to show you how a 3D image would look on a 2D paper. So like if you're trying to map out, let's say, a hill or a mountain, it's important to know how steep certain parts of it are. So, and you obviously can't draw a model and put it into a map, so what they do is they use these lines. They're called contour lines, and they're basically, their job is to show you how, the elevation or how high something is on a map. So if you look here, the first step you're going to do is look at the contour interval. That tells you how tall each line is. So basically, each line is going to go up 500 feet. So this entire first circle, all the way around the map, is going to be equal to 500 feet. Then the next circle is equal to 1,000. and then 1,000, 500, etc., until you get all the way up to the very top, which is going to be about 4,000 feet. Now, the closer the lines are together, the steeper the hill is. The further they are apart, the less steeper, the more gradual the slope is. So if you look over here, this side right here, the lines are very close together, making the hill very steep. On the other side, the lines are a little bit further apart, making the slope is very gradual. In the picture up at the top, you can kind of see it. The hill goes up very quickly here, but far more gradually over here. They both go to the same height, however, one went up a little bit quicker. Now on the STAR test, this is how the questions are basically going to work. They'll give you a map, kind of like this, and they typically give you the contour interval. Then they'll ask you basically to find like the distance between, let's say, D and C. And all you do is simply take the starting point you have, which would be 1,000 feet. Go ahead and write that in. 1,000. And then you subtract it from the height that you're supposed to end at. So this is going to be 1,500. And you're left with 500. Basically, that means you would climb up 500 feet to get, 500 meters to get from D to C. Now, they're not always quite as easy as that. Sometimes they're a bit more difficult. So let's go ahead and try one that's a little bit harder. Let's say that we were going to hike from point B to point V. So we're walking up here. And you want to know how high you're going to go. Well, first off, you need to find out where B is. So if y'all look here, it's basically going to be 100 feet up from 800, which would be 900. So your starting height is going to be at 900 meters. And your ending height is, if you look here, this one right here is marked, sorry, let me get that little arrow in there. This one is marked 1,500, and it's one line above that, so you just add 100 meters onto it, so it'd be 1,600 meters up to point B, and you subtract your starting from your ending, and that would give you your height you've climbed. So you subtract 900 from 1,600, which would give you 700 meters. You basically would have climbed up 700 meters. Hopefully this was helpful, and you have a great day.